Your goal for today is very simple. I want you to just try to wrap your head around what we're talking about. We're starting to get to that point in the year where trying to understand this starts to hurt your brain. At least my brain hurts.
If you've only learned one awesome thing about astronomy and the giganticness of the universe, it's probably that the universe is 13.8 billion years old, space itself is expanding, and our observable universe at 93 billion light years across is accelerating in its expansion, such that someday all the objects in the universe might eventually fly apart, never to return. But the second thing you might have learned about is the Hubble Deep Field. If you have heard of the Hubble Deep Field, I apologize, but I have to remind you how awesome it is. If you haven't heard of the Hubble Deep Field, it's basically this. In 1995, scientists chose the darkest patch of the night sky and focused the Hubble Space Telescope there for 10 consecutive days. The patch was only 2.5 arc-minutes across. As a refresher, astronomers measure distances in the sky with angles, because these two stars would appear to be the same distance apart as these two stars, and of course, they're not. But they are at the same angle. In the entire sky around us, there are 360 degrees of angle, and each degree has 60 arc-minutes, just as every hour has 60 minutes. Now, of course, we can measure the angle of two different dimensions, so we get a square of angles. That is 2.5 arc-minutes across. If you filled the entire sky with these squares, you would need 23,800,000 of them. Bottom line, the area of the Hubble Deep Field is tiny. They took this piece of the night sky and focused the Hubble on it for 100 total hours. You can imagine what a risk this was for astronomers. Time on the Hubble is extremely competitive, and no one knew if they would find anything interesting in such a tiny, dark piece of the sky. Well, this is the image they came up with. The darkest part of the sky. See all those dots? Most, if not all of them, are galaxies. There could be a version of Physics Girl in any one of those dots. This image was the first to look back at the oldest galaxies in the universe. In doing so, we learned so much about the universe that scientists decided to do it again with the Hubble Deep Field South, the Hubble Ultra Deep Field, and the Hubble Extreme Deep Field. Oh my gosh. If this was your first time seeing the Hubble Deep Field, I envy your emotions right now. This picture is just another reminder of how huge our universe is, how much is out there. I am honored to have been the first to bring it to you, as Neil deGrasse Tyson was for me. So, may you go enjoy the grandeur of the universe.
Here is the image that she was talking about, the Hubble Deep Field, where every single one of these specks of light is an entire galaxy with billions, hundreds of billions of stars. Every single point of light on here is a galaxy with hundreds of billions of stars. Just think of how many stars are in this photograph that we're looking at right now. How many planets are in this photograph, if there's that many stars. How many aliens are in this photograph. And this is just this much of the sky. Aliens have to be out. They have to be. There's just too much stuff out there. Just how much of the sky is this?
Have you ever wondered how big the entire universe is? The visible universe is unimaginably huge, but there is one image that can give us a small glimpse at its awe-inspiring scale, and that is the Hubble Deep Field image. In 1995, astronomers wanted to see what would happen if they pointed the new Hubble Space Telescope at an area of the sky that was nearly devoid of all stars. They let it soak up light for over 140 hours over a span of 10 days, and what they saw was nothing short of spectacular. This is the Hubble Deep Field image. What you're seeing here is not just a few stars, nebulas, and star clusters, but each and every dot and fuzzy patch you are seeing is an entire galaxy, each containing around 100 billion stars. To get an idea of how many stars are in each one of those galaxies, imagine an Olympic-sized swimming pool and fill it with standard 1.5 centimeter marbles. If my calculations are correct, taking into account the max density of close-packed spheres, It would fit around 1 billion marbles. That would mean we need 100 Olympic-sized swimming pools full of marbles to equal the number of stars in an average galaxy. In a similar, more recent capture called the Hubble Ultra Deep Field image, we can see around 10,000 galaxies, each with around 100 billion stars. Pretty cool, right? But you haven't heard the most amazing thing yet. This image is not the entire sky, far from it. This is only a tiny fraction of the sky, 1/13 millionth to be exact. Look at the size of the D on the front of an American penny, then hold the penny up to the sky at arm's length. The area of the sky that the Ultra Deep Field image takes up is roughly contained entirely in that tiny D. The Hubble Deep Field images allow us to peer deeper into space and time than we have ever seen before. I say deeper into time because some of these objects are so far away, the light coming from them has taken up to 13 billion years to get to us. So we're seeing them as they looked less than 1 billion years after the Big Bang, long before the Earth was even formed. Some of these distant objects are called quasars, which are the most powerful and luminous objects in the universe. Even though they're only about the size of our solar system, they emit up to 1,000 times more energy than the entire Milky Way galaxy, which contains between 200 and 400 billion stars. They're made up of supermassive black holes that are consuming so much material that they shoot giant jets of particles traveling at nearly the speed of light, thousands of light years into space. Yeah, quasars are pretty awesome. Looking at this image is a humbling experience, but to me it just shows how amazing our universe is and how much there is left for us to explore. It's almost unfathomable that we could be the only life in this vast universe. Peer into this image long enough and you'll start to imagine what awe-inspiring wonders could be hiding in those distant galaxies full of billions of planets.
Some information for you guys. This original Hubble Deep Field was taken in 1995, only about a year after Hubble was fixed. It's 1/24 millionth of the whole sky. So just think that every speck of light is an entire galaxy with billions and billions of stars, and who knows how many planets. This picture is 1/24 millionth of the sky. You'd have to multiply this by 24 million in order to cover the entire sky. There's a lot of stuff out there. There's got to be okay. Hubble actually spent about 10 days taking over 300 photos, and then they stitched them all together. And this was the darkest part of the sky that they could find, because they didn't want anything that they knew about in the foreground to cover anything up. So they literally searched for the darkest, emptiest, nothingest, blankest, just nothing there part of the sky, and found more galaxies. It blows my mind. And it worked so well that a few years later, they did it again. The first one was in the northern hemisphere, so they pointed Hubble towards the southern part of the night sky, and again found the exact same thing. And you can start to see some of the closer ones that are a little bit bigger. You have some spiral arms, you have some elliptical galaxies, you can see that there are different colors. You can start to see individual galaxies, but like every single speck is hundreds of billions of stars. I can't wrap my brain around that. If you can, you've got a bigger brain than I do. The first two worked well, so let's do it again. This is known as the Ultra Deep Field. This is not 10 days worth of data, this is a couple months worth of data. So it actually covers a little bit bigger area of the sky, and it's estimated that there are 10,000 galaxies in this, each one with hundreds of billions of stars. The farthest ones away, the faintest, tiniest ones that we can see, are about 13 billion light years away, which means the light from these galaxies left those stars just a few 100 million years after the universe formed. So these are the first galaxies that ever existed in the entire universe that we're looking at in this photograph. And again, you can see that there are some old galaxies that are very red. You can see some bluish or white galaxies that are a little bit younger. You can see spiral arms, you can see irregular. There's a plus sign, which means that's a star in the foreground. Speechless. This worked really well. So we kept looking at this part of the sky. We kept taking photos. We kept Hubble, whenever there was some free time, we turned Hubble back and said, keep looking. And 10 years later, we came up with the extreme deep field. And they went from 10,000 galaxies to over 15,000 galaxies, just in one photograph. Now that Hubble has looked at this for 10 years, let's turn other telescopes and look at the exact same part of the sky. So here's the original Hubble Ultra Deep Field. All of this is only visible light. Let's add in ultraviolet light. And you can tell that there is quite a bit more out there that you don't see in visible light. But when you add in ultraviolet light, you definitely see that there's more stuff. So in 2004, we took this photo. In 2014, we ended up with this photo. And this photo is what's inside of this red box right here. And this was, what, 10,000 galaxies in this first photo? And, I mean, just, there's a lot of stuff out there. I'm going to pause the video in just a second because I want you guys to make this in your science journal. And I'm going to give you a link to the actual Hubble Deep Field photograph. And I want you to just go over and count. How many stars do you see and what color are they? Just tally, like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many elliptical galaxies do you see and what color are they? How many spiral galaxies? How many irregular galaxies? So if you see a spiral galaxy that's white, just put a little tally mark. If you see an elliptical galaxy that's yellow, put a tally mark. If you see a star that's red, because of the plus sign, put a tally mark. Spend a few minutes and do that. Here is the link. Now that you've done that, I want you to answer these questions. Was there any sort of pattern or correlation between the color and the type of galaxy? And what do you think that means? What was the most difficult part of doing that? And finally, that photo that you just looked at, how many total stars, not galaxies, total stars do you think are in that single photograph? The background of this slide. Here's my personal hero explaining what it is.
The Hubble telescope, let me remind you, was the world's first orbiting observatory specializing in visible light. Ordinary light that our eyes are sensitive to. It's an ordinary telescope that has been endowed with the capacity to do extraordinary things. It's a space-based optical observatory. We put it out in space, lifted above the atmosphere of the Earth. What could Hubble possibly do for us that we haven't already done here on Earth? Here it is. That is the Hubble Deep Field, one of the most boring parts of the night sky. And what does it reveal? Thousands of galaxies. Practically every splotch of light in that image is an entire galaxy, not much unlike our own Milky Way, bearing hundreds of billions of stars each. What's extraordinary about this image is, given the precision of Hubble's imagery, you can get close to the picture and look in on the galaxy. I've seen pictures sort of like this before, taken by ground-based telescopes, and it's got just as many galaxies, but they're just all smudges. They're just smudges, and I look at it and say, okay, you get a little closer to the smudge, it's just, I'm closer to a smudge. Here, as I look real close, I can see structure, I see spiral arms, I see regions of extra star formation, I see different colors. Some galaxies are larger, they're likely closer. Other galaxies are smaller, they're likely farther away. Where does it get the colors? Why are some galaxies blue? Some stars are blue. Those galaxies are highly represented in that species of star. How about the red galaxies? Some stars are red. Some stars are white. We have red, white, and blue and everything in between. But I do know that this Hubble Deep Field for me is a window, and I think of reaching out through this window. And I reach through it. Someone has actually turned it into a window spread out in 3 directions. A colleague of mine, Ken Lanzetta. took the Hubble Deep Field and took all the galaxies which are spread through time and distance and created a fly-through of the Hubble Deep Field, adding the dimension of distance to it, which makes it that much more compelling to me as an intellectual journey, as a place to gaze upon and wonder, especially since that gaze is a gaze that takes you to the edge of the cosmos. When you go out under the night sky and look up, what are you doing? You're stargazing. But when I look through this window that is the Hubble Deep Field, I galaxy gaze. I galaxy gaze through time. And in so doing, I revel in the diversity of colors and forms and shapes and structural detail exhibited in the objects of that photo. And when I do this, the boundary between my knowledge of the cosmos and my ignorance calls to me. And when I reach for the edge of the universe through the Hubble Deep Field, I do so knowing that along some paths of cosmic discovery, there are times when, at least for now, one must be content to love the questions themselves.
Here's the link for that ultra deep field with 15,000 galaxies, both in visible light and in ultraviolet light. It is like 100 and some megabytes big. It's huge. If you want to download it, make it as a background to your computer, you can. Here's the link. And when you take that photo and you just take a little section of it and you zoom in, take another little section of it and zoom in, and every single little tiny speck of light that you see in this photograph, every single one is an entire galaxy with hundreds of billions of stars. And each star might have 10 or so planets. How many aliens have to be in this photo? This is why statistically I think there has to be aliens. There's just too much stuff out there. I mean, here's a galaxy that's pretty close. You can see the spiral arms. Like, there's a lot of stars in this galaxy. There's got to be a lot of planets. Are there aliens in that galaxy looking at the Milky Way right now thinking, man, are there aliens in there? And again, just like when I was talking about neutron stars and black holes, I am speechless because, and I'm going to be a lot more, and I'm going to be a lot more until the end of the year, because this stuff is why I love astronomy. This stuff is just, makes your brain hurt. Aliens.